Welcome back to your MATLAB mentor, where MATLAB turns math into motion. Let's go to smarter, not harder. Opening up a new episode. Today we will continue our talking about plotting, but we're gonna discuss different aspects and different types of plotting. So please make sure that you have saw already the second and third episode, especially those because they are all about plotting and we're gonna build upon them. As everything just like depend on each other. And as always, please make sure you have your laptop open, your MATLAB open, and apply as we are going step by step. Because learning is always through applying, through getting your hands dirty and try every code, each line by yourself. So let's begin. Okay, today we're gonna try plotting a histogram. A histogram is very powerful plotting. It's used in different aspects in different sectors, whether finance, engineering, college students, statistics, calculus 3, all of this require histograms or has the histograms. So let's begin. As always, I have to specify a data. This time there's gonna be something. I love MATLAB how like he always like write description rand n normally distributed random numbers, and this is the function we're going to use especially with the histogram. And I'm going to just say what this means, and let's make our vectors from 1 to 1000. So what's the random distribution random numbers? So basically random numbers is just like a quick recap. Random numbers give me three things. Make sure that the histogram are centered at 0. So we're gonna see like the center of the histogram will be at 0. So it is in the middle. Okay, this normal or like, yeah, it's normal distribution. And also symmetrical. Symmetrical, it means like it does looks like a bell shape, like going up and then going down. And we're gonna see it once we like actually plotting it. And the third thing, the x-axis will range from -3 to 3. Okay, so let's write this real quick. So it's symmetrical and it does ranges between 3 and between -3 and 3. So that's why I have to use like normally distribution random numbers. And what means by 1 and 1000? This means basically that you are telling MATLAB, okay, please create for me one row with 1000 columns, random numbers between -3 and 3. So if I press run right now, one row with 1000 column. All those values is within -3 and 3. That's why it's randomly normally distribution. So this is very important for histogram, and this one condition of histogram that it has to be normally distribution or normally distributed. Okay, let's keep going. Then I have to call this like figure maybe 1 semicolon. And basically if I want to plot a histogram, you guys guess what? The function is also histogram. Here we go, histogram plot. And let's for now say data. Let's see what we get. Okay, so as I said, I just want to make sure normally distributed, so it's centered at 0, symmetrical. Symmetrical means goes like up and down as a bell shape. Unsymmetrical, it wasn't be this one, like it will be has out layers, which like most of those tall pens will be towards the right, or which of those two pens will be toward the left. So right out layers or left out layers. And also it ranges between -3 and 3. That's all like function of histogram. And we can apply all the properties that we do apply at any other plot. So let's write like x label something like value, maybe font size 15, y label, frequency, same thing, font size, title, histogram of normally distributed data. And I think it's very important to make a correlation between the normally distribution and the histogram because they are actually relevant to each other. Font size 15. This will make our plot looks way like more defined. Okay, but this sweet for like plotting a histogram, but histogram has a powerful property and I wanna discover it today with you guys. So as I said before, like MATLABs can always give me an options of everything, and as I said, every function has different option. So today I want to discuss normalization. So what normalization means with the histogram? Normalization, it just controls how the y-axis value are scaled, and depend on how the y-axis will be scaled, it of course will impact or like affect my histogram. So like count, this is the default one. So if I press run right now, count it just like give me the numbers, numeric values for y-axis, like count just number of data points at each pen. Pen is PYN, which means like each column of this is the rectangular one. Okay, this is called pen. So yes, so normalization, it will make my y-axis it just like values or numbers. Okay, one more thing about that, also like it's from the options, it's called probability. Okay, what means by probability? I'm gonna turn my y-axis to percentage of the total data, and this is very, very powerful. So right now, if I press run, here we go again, like it gives me 0.02, like 2%, 4%, 6%, 10%, and so on. So it just, this is very powerful if you want a relative frequency. And also like if you, it has a lot of application, like you can use a probability with histogram, like for example stocks, depend on like how stocks increase to how many percent, 4%, 3%, 2%, and you can like instead of these numbers you can just like put labels or like different stocks and compare them to each other. So you can do this by probability because they're gonna give you the percentage in the y-axis. That's awesome. Okay, what else we can use? Okay, here is kind very relevant if you are studying engineering or like finance or like application engineer. BDF is not the program apparently. It's just something in the statistics, okay, called probability density function, and it's also very relevant to MATLAB. What this means? Okay, step by step. So it just does it scales the height of each bar to make the total area under curve equal 1. So what means the total area under curve equal 1? Basically or simply, it just makes the y-axis ranges between 0 and 1. It's very important, and like you can use this when you are comparing histogram with different samples, or you want to compare two histograms together or two data set with each other. So using probability density function will be very good because it just makes the entire area under curve equal 1. So gonna make it very obvious, like presenting wise. And also statistical modeling, as I said, because it will help you to understand the shape of your histogram more. So let's try to run it. So yeah, it's between 0 and 0.45, which is still 1. And like it's still like between 0 and 1. and it does give me like little bit presentation, or like help me to figure out how my figure looks like. So it's powerful of comparing data or any like type of modeling in general. And PDF, please take notes of this as we go, because you guys just don't know when you can use all of this. But when you have like notes, whether like on laptop or anything, or like comments, all of this you can go back and review everything we do like discuss here. Okay, so BDF, probability density function. Okay, last option I would like to discuss today, CDF. CDF, it's mean cumulative distribution function. What does this mean? Okay, it just plots the cumulative total of the data up to each pen. Cumulative total. So cumulative or accumulates. I do imagine accumulates as like something can get inside thing. So if I do have water bottles and I'm measuring water, I can use a CDF to measure how the water will be filled inside those water bottles, because it's gonna accumulate inside the water bottles. It came from this concept. So how each data accumulate at each pen. So it's also gonna turn my y-axis from 0 to 1, and it's just like very useful when you wanna see how data accumulates. And basically if you are like measuring data that could be accumulates apparently, and also like percentile based behavior. So percentile in statistics, it's something like the median or the mean. All of this is under our examples of percentile. It's very like mathematical expression, but it's also CDF. It's important to know that this used for this. So let's compare real quick. So if I want to use the probability density function, I can use it like if I want to know, like for example, how tall are the hills is. Okay, but if I want to use the cumulative distribution function, I can use it to see like how much water has filled in each water bottle. So it's very like different, but everyone is very important to know all of this and taking notes of all of this, because this basically fundamentals of knowing the histogram. The next property I do want to discuss is the pen width. So what's the pen width? So for example, is also very powerful in the histogram. So the pen width, let's see if I wanna, it doesn't give me a default number, but it's usually between 0 and 1. So it's very obvious. I said, like I mentioned before, the pen, it's all those like the column of the histogram, width. So the width of how like I can change the width, whether like 0.5, 1, how long, how small. And basically a smaller pen width will give me more bars and more details. A larger pen width will give me fewer bars but a smoother like shape. So it's inverse relation. The smaller the width, more bars, more details. Larger the width, fewer bars, and of course fewer details. This is very important for clarity. Like let's see if I want to do like 0.8 pen width. You guys can see less details, right? But if like I want to make it 0.1, huge details, a lot of data. And yeah, I can adjust it as I do, because like it's, as I said, it's very important, like if you are for representing wise, if you want to focus or like emphasize on a specific data, not on the other one. Okay, moving forward. Now let's create a bar graph. Okay, let's make a deal. So the deal is humans cannot survive without air and water. All of us agree on this. Okay, same thing. The bar graph cannot survive without category names, which is as like labels, texts, anything that has letters, okay, and their values. So human cannot survive without air and water. Bar graph cannot survive without category names and the values of those category names. Sounds good so far? Okay, so let's create category. So categories, equal curly brackets. Curly brackets. This is not actual brackets. This is the curly brackets. I just shift and I will press the brackets. Will give me curly brackets. And we're gonna explain why we did use it, because there is a reason behind it. This is character vector. We explained in episode 1, I do remember the difference between one comma and double comma. The one comma is character vector, double comma is string vector. Okay, and then like let's write here like something bananas. Apparently they are all fruits, so cherries maybe, and dates. Let's close it. And give me cell array. Okay, 1 row, 4 columns, cell array. So basically I use curly brackets because it gives me a cell array. Cell array, it just able to accept different data types, which is very, very useful for like anything related to text or like letters or labels or names. So basically just like moral of the story, when you are using any names, use curly brackets. But if you are using numbers, use the actual brackets, which is like this. Okay, but let's try what happens if I like copy this. You guys remember when I said like command window is good for oh my god, okay, is good for texting, not testing. Like if you want to test anything, command window is helpful, but like the editor is good for scripting. That's why right now I will try on this. So let's see if I did brackets instead of those curly brackets. So the actual brackets, it's glue all the string. It gave me just one long single string. So that's why like this, the brackets only is very important, but for numeric value. But the curly brackets, because it's cell array, and as I said, different data types, so it's very good to do whatever categories you want, because some categories might has like $sign, percentage, all of this will be like very helpful with curly brackets, not the regular brackets. So good so far? Okay. Let's keep going. Let's put like values. So water and air and water, okay, categories and their values. So 1, 2, 3, 4 values also, like I have to give 4 values to match the number of categories. So right now 23, 17, 35, and 10. Semicolon, semicolon, CLC. Let's press run. Okay, now is the orange workspace. Okay, let's name this figure 2. Then par values. Let's see what we might get. Interesting, but this is not what I do expect. Like I do have here 1, 2, 3, 4. Like I have values, but as I said, the bar graph needs 2 things, right? Categories and their values. Like he just gave me the range between the values, like all the values within like 0 and 35, which is fine. Like this is the range of my values, but this is not enough. Let's change this. Let's change my x-axis. How I can do this? Here we go. So I can set, and set is set graphics object properties. Graphic object properties, which is like x-axis and y-axis. Okay, GCA, current axis or chart. As in the last episode, right, we're having a marker CEO, right? Today I have GCA is axis manager. In general, what the manager do? Gives permission, right? So in order for me to change the x-axis, I have to ask first the axis manager, which is get current axis. This is the abbreviation. This is GCA, get current axis. I'm just telling MATLAB, okay, I get the axis manager, which I want to change the x-axis from numbers to anything I do want, which is, in our examples, is the categories. And I will do this axis manager. I have to choose which type, or like x axis, y axis. So right now it's x axis, so x tech label, and instead of numbers I'm gonna use categories. Okay, let's see what we might get. Here we go. So I change from numbers. Okay, now my own categories, which is apple, bananas, cherries, and dates. And I did this by the axis manager, get current axis, using x tech label. X tech label is basically like I'm telling MATLAB, or you're gonna set custom labels for the x-axis, any custom labels, any labels. Okay, for the x-axis, it's like just replacing the default numeric labels to your own custom, which is, as I said, categories. Okay, so I did this, get current axis, x tech label, and this is how we can just basically like change it. And you can, of course, like this example is fruits, you can go from there. And as I said, you guys are already like very confident with this, but like, yeah, let's make it more sweeter. So X label, let's make it like fruit type, font size 15, Y label, quantity, solid, same thing, like font size 15, title, fruit sales data, maybe font size also 15, semicolon, semicolon, way better, right? Okay, so as I said, as the histogram has its own properties, same thing as a bar graph. Bar graph, one of the most important thing in the bar graph is the error. How we can see your error in your data, or how we can measure it. So as a bar graph is very unique, as we can see here. I can also like represent how far my error is, or like if I do have error in my graph. So overall, because this is just an example, so I don't have a real data with real errors, but I just want to mention that errors comes from two sources. STD and the standard error. What each one means. So STD is standard deviation. I believe you guys took this whether in high school, maybe in college, but simple words, I don't want to go in depth. I just want to like fundamentals, like information about how I can get error with actual like data. It just standard deviation simply means how spread out your data from the average mean. So basically your data is above average, below average, or like if it was above average, okay, how far it is above average, because this is very important. Like if you like want to compare, like let's say example, like you're a student and you are comparing a grades. So there is a class average and you want to measure yourself whether you are above average or below average. Standard deviation is good for doing this. This is not an error, but basically like this is how like standard deviation might like see if there is an error or not. So I said like just grades, but like if you are working on a project or like mechanical equipment and like you're saying like the temperature it should be like 10 Celsius or 10 Fahrenheit or 50 Fahrenheit or whatever the conversion, but then if the temperature is above that or below that, this of course a big error or a big problem. So that's why it's helpful. But this usually how we can find error. Standard error calculation wise is just a standard deviation over square root n. What's n is the number of values, which is in our example is just 1, 2, 3, 4. To find the standard error, here is what you can do. Have the standard deviation divided by square root number of your values and you will get the standard error. Okay, what the standard error measures? It just measures how precise your average is. Okay, so I'm saying this because this is usually in any data set how you can like find an errors. Of course there is another like ways, another tools to find an errors, but basically those two of the most famous ones. Okay, for a real data, but as I said, just not a real data, so I'm gonna set my own errors. So let's make here an errors. 2, 3, 4, 1.5. So 1, 2, 3, 4. Okay, because I have 4 categories, I have 4 values, so basically I'm gonna have 4 errors. Matching the sizes goes long way. 1 multiplied by 4, 1 multiplied by 4. If I run this right now, I'm gonna have 1 multiplied by 4 as well. Good to go, because it might get a lot of error functions if we have a lot of data. So I just want to mention this. Okay, what else should I do? So error is just as you are dealing with different plotting, or you are actually coding or making a different plot in order to present an error with the previous plot. So which function can do this for me is hold on function. And we discussed this in the second episode, so please make sure to go back. And I will just like recap very quick. Hold on and just make, you are saying to MATLAB, the next plot, I want the next plot to be with the previous plot. So it actually mixing 2 plots in just one figure, which is will be here figure 2. So hold on, MATLAB expects you to write another plot. So another plot, so we have to measure here the x-axis of the error plot, or like the plot that has an error, which is we can write something like from 1 to length of values. Okay, what I'm doing, why I do write this, like as now it's like I think very obvious, but I'm just telling MATLAB I wanna the x-axis to be from 1 length of values. Length of value, we took this in the first episodes, mean just the number of elements of values, which is 1, 2, 3, 4 here. Like if I write length and I did write values, I'm gonna have 4 because they are 1, 2, 3, 4. So the x-axis will be ranges 1, 2, 3, 4. Okay, so that's why this is the range of my x-axis. And then error bar, line plot with error bars. Yeah, so there's a function. So error bars, line plot with error bars. So first things first, x-axis, which I already make it here, would be x. Okay, then y-axis, which I do have it also here, values, and we can see here x from 1 to 4, so it's 1 multiplied by 4, and values is also here 1 to 4, so they do match. and surprisingly error is also 1 to 4, so it will match. So okay, just I want to mention error bar, so x-axis, y-axis, and then the errors, the data that has an error that I did get, which is in real data, as I said, might be from standard deviation or standard error. So I can write here errors, which is was you're gonna like refer this blue. So errors, it means like 2, 3, 4, 1.5, which is under name errors will be like, it just this blue, it just matching the names. Okay, so let's try run this. Here we go. Okay, so here's the error is representing like this one, this two, this three, this four, the x-axis as we did here from 1 to 4. Okay, so 1, 2, 3, 4, and hold on, it just makes the two plots together, like the bar graph and also the error plot, both are represented in front of us together in just one. And I can just like this, not obvious little bit color wise, so we can make this K. Okay, I think it was K small, and maybe let's do line width, the default 0.5, let's make it as the default 0.5, oh yeah, 0.5, let's make it 1.5, my bad. Okay, let's see what we get. Here we go. Okay, that's sweet. So okay, now it's black. Okay, line width 0.5, so we can see the error width is 0.5, and I can see the error within apples, within banana, within cherries. So I can see the error of how tall those bars are. The more it's taller, the more the error increase, and they match it to each other. Okay, so this basically how I can like insert an errors on a bar chart. I can just like error style, and this, as I said, this why MATLAB is very helpful in this sequence, because instead of error he expect to be string, and I can just like it choose from bar color instead of doing this, and maybe make it red and becomes red, but red I didn't like that much. Let's make it something like color cyan. So as I said, every function has its own rules, and this is the same thing. So it's basically is very helpful if you want to like do this, and you can have like you can reach to the color style options, you can customize as you do want. I can see what the style is tagged, grouped, and we applied this in the episode 3 with the tiled layout, but let's for now make like cyan, and I'm gonna give me the cyan color. Okay, so finally now it's time for our mini assignment. Today's mini assignment, I want you guys to practice customizing histograms and bar charts using MATLAB plotting functions. Of course, like functions that we discussed today, like including normalization for histogram and x tech label, and finally error bar. So please make sure to do this assignment, mini assignment. Make sure to go through all of this again by yourself and try different stuff. Get your hands dirty, practice, because now we are reached to the end of our episode. Okay, Please feel free to ask any questions. I will be super happy to answer all of them. And as I said, practice programming is all about practice, and practice makes permanent. Thank you all, and see you next episode.